Welcome to episode 37 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data and AI with you.
And I'm Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Cars are becoming computers on wheels.
That's right. Our vehicles aren't just machines anymore. They're smart, connected systems powered by AI. Today, we're diving into how AI is reshaping the automotive world.
Let's start by looking at what AI actually brings to cars. At the heart of it, AI in automotive revolves around turning data from the vehicle's many sensors into meaningful decisions. Think of autonomous driving, cars that can perceive their surroundings, understand the environment, and decide how to act without human input.
From working with automotive clients, I've seen how companies are pouring massive investments into those sensors, cameras, radars, lidars, and then time them all together with AI algorithms. The goal? Safer, smarter cars that can reduce accidents and improve mobility.
Exactly. Autonomous driving is essentially about creating a system that can mimic the perception, reasoning, and decision-making of a human driver. It starts with sensors capturing vast amounts of raw data, like images, distance measurements, speed, and more.
To put it simply, those sensors are the car's eyes, ears, and skin. Cameras let the car see the road and signs, radar detects objects in bad weather, and lidar gives a 3D view of everything around. But the magic happens when AI processes that data to understand what it all means.
Well said. The AI systems use machine learning models trained on millions of miles of driving data, patterns of how objects move, how to recognize pedestrians, traffic lights, road markings, and then make split-second decisions. But this is no easy feat. It requires advanced computer vision, sensor fusion, and real-time data analysis.
And in practice, this tech is already in cars on the road. Tesla's Autopilot, GM's Super Cruise, and Waymo's fully autonomous test vehicles showcase where AI-powered mobility is heading. But it's a spectrum from advanced driver assistance systems like adaptive cruise control and lane keeping to full autonomy.
That spectrum is important to grasp. Levels 1 and 2 autonomy mainly assist the human driver, while levels 4 and 5 represent full autonomy, where the vehicle can handle all driving tasks without human intervention, at least within certain environments.
But getting to level 5 is a huge challenge. One reason is unpredictable real-world conditions, weather changes, road construction, or unexpected behavior from other drivers. The AI needs to be incredibly robust and constantly learning.
This is where continuous data collection and model updating come in. The vehicle's AI must adapt by incorporating new data from millions of miles driven to improve its perception and decision-making. It's an ongoing learning process, much like humans improve their driving skills.
Another exciting use of AI in automotive is predictive maintenance. By analyzing data from vehicle sensors, AI can forecast when parts might fail. This helps companies reduce downtime and save costs. A direct, measurable impact on operational efficiency.
Right. Instead of following fixed service schedules, AI enables condition-based maintenance. The models analyze vibration, temperature, and other sensor readings to predict wear and tear before a breakdown happens.
In one recent project, we helped a fleet operator reduce unexpected truck breakdowns by over 30% using AI-driven maintenance insights. That's a direct, measurable impact on operational efficiency.
Moving beyond individual vehicles, AI also transforms entire mobility ecosystems. AI optimizes traffic flows in smart cities by analyzing data from connected cars, infrastructure sensors, and GPS. This reduces congestion and emissions.
I remember working with the City Transit Authority that integrated AI-based traffic management. By dynamically adjusting traffic lights and rerouting vehicles, they improved average commute times and cut pollution. It's a great example of AI's impact outside the car itself.
So, in summary, AI in automotive is a blend of perception, real-time decision-making, predictive analytics, and ecosystem integration. It's an exciting frontier combining several complex technologies.
But it's also not without challenges. Data privacy, safety regulations, and ethical questions about autonomous driving decisions remain hot topics. Trust and transparency are critical for adoption.
Absolutely. From a theory perspective, creating AI that is reliable and explainable in such high-stakes environments demands rigorous testing and validation frameworks.
On the ground, I've seen companies balancing rapid innovation with regulatory compliance. It's a delicate dance, but the potential benefits, saving lives, improving efficiency, and enabling new mobility models make it worth it.
Before we wrap up, let's touch on one foundational concept, sensor fusion. This involves combining data from multiple sensors to create a more accurate understanding of the vehicle's surroundings.
It's like having multiple senses work together. Imagine if you only had sight but no touch or hearing. Your perception of the world would be incomplete. Similarly, cars use sensor fusion to fill in gaps and resolve ambiguities.
Exactly. Mathematically, sensor fusion often uses techniques like Kalman filters or deep learning-based models to synthesize data streams, filtering noise and improving precision.
In practice, better sensor fusion means the car can, for instance, detect a pedestrian partially obscured by a parked truck, even in low light or bad weather. That's a big safety boost.
Amy, this balance between complex theory and practical application is what makes AI and automotive so fascinating.
Definitely. It's one thing to design algorithms in the lab and another to see them navigate a busy city street safely and efficiently.
So to close, my key takeaway is that AI's role in automotive extends from deep sensor data processing to whole mobility ecosystems, requiring interdisciplinary approaches and constant learning.
And my takeaway is if you're in automotive or any industry affected by mobility, understanding these AI advancements will help you spot real opportunities to improve safety, efficiency, or customer experience.
Next time, we'll shift gears into finance and explore how AI transforms that world.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We love hearing from you, so don't hesitate to leave questions or comments. Your input might show up in future episodes.
Amy, until tomorrow, stay curious, stay data-driven.